to another theory of computation tutorial. Today we'll be learning about how to complete a DFA and what are regular and non-regular languages. So let's get started. First thing, let's look at the list of topics that we are going to cover today. First, we'll look at how to figure out what a DFA recognizes, then how to complete a DFA, then what are regular languages and what are non-regular languages. Alright, so let's get started. First thing, let's see, we have got a DFA over here. Okay, this is the DFA that we have, and we want to find out what strings does this DFA recognizes. Okay, so let's say we have a string 001. Does this DFA recognizes it? Let's see. So you get a 0. This is the starting state. Okay, you get a 0 over here, and you go over here to B. In B, you get another 0. You are still in B. Okay, you get a 1. You go to state D. Is D a final state? Yes. So this string is recognized. Okay. What about string like 0, 1, 0? What happens over there? Well, you go from state A. When you get a 0, you go to state B. You get a 1, you go to state D. But what after that? Nothing is mentioned right over here. So we don't know what happens over here. Till now we don't know. Okay. What about string 1, 0? So you get 1 in state A, you go to state C. And then in state C, you get a 0, you go to state E. Is it a final state? Yes. So this string is accepted. So this DFA recognizes strings starting with 0, with at least one 0. At least 1, 0 and ending with 1. For example, 0, 1, 0, 0, 1, 0, 0, 0, 0, 0, 1. Okay, these are the type of strings this DFA recognizes. Also it recognizes 1, 0. This string also it recognizes. Okay, so these are the two type of strings this DFA recognizes. Alright, now let's look at how to complete this DFA. So this is the example of completing this DFA, because we didn't know what happens after we reach the final state and you get another input. Correct. So let's say we have a string like 1, 1, 0. What happens over here? So you are in state A, starting state A, correct? You get a 1, you go to state C. You get another 1. What are you going to do now? It's not given. So what we do is wherever it is not given, we create a trap state for it. Okay. So let's say we are in state C and you get an input of 1. You create a trap state for it and we'll call it state T. Okay, state T. Now in state T, you reach when you get a 1 from state C. What about state D? Any input like 0 or 1 you get, you go to state T. Okay, so 0, 1. And for state E also, it's incomplete, right? Because we have not mentioned what happens if you get input over here. For state A, we have what? As in like, if you get input 0, you go to B. You get input 1, you go to state C. For B also, we have got, if you get a input 0, you are still in B. If you get an input 1, you are going to state D. Now D is also complete. If you get 0, 1, you go to state T. For E also it is incomplete because you have mentioned if you get a 0 or 1, you go to state T. What about C? 0 and 1 is also mentioned over here. But state T is still incomplete. So we'll loop it back to itself because it's a trap state 0, 1. Now this DFA is complete. So any string over here will be processed now. So let's see, we have got a string 1, 0, 1, 0. Okay. So let's say we start from A. You get a 1, you go to state C. You get a 0, you go to state E. You get another 1, you go to state T. And you get a 0, you're still in state T. Is T a final state? No, it's a trap state. So this string is not accepted. Okay. So this is how we complete a DFA that is incomplete. Okay. Now, what are regular languages? A regular language is said to be a regular language if and only if a FSM recognizes it. That is, you can draw a DFA for it. Okay. So let's see, look at an example. First, what are non-regular languages? Languages for which you require a memory to either store a string or to keep a count of the string for the reference. So let's say, for example, we want to create a string with the pattern A, B, A, B, A, B repeated 1000 times. Okay. Can we do this? That is, can we construct a DFA to satisfy this language? Manually we can create a DFA, but it's impractical because then it is done manually, right? You cannot call it an automaton. So what I mean by that is, let's see, look at an example. Okay. So what is a string? A string is AAB, 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 okay, and so on 1000 times. Now manually doing it is very difficult and impractical, and it cannot be called automaton, because automaton means it should recognize it automatically. So For example, let's say, yeah, okay. So let's say this is our A B string. Okay, I'm just drawing basic for first this thing. Okay, so let's say this is the starting state P. You get an input of A, you go to state Q. You get an input of A, you go to state R. You get another input of B, you go to state S. Okay, and let's make this a final state. Okay, now if we think that we can create a pattern over here like this, that you get another A over here. Okay, so you will be looping it through this again and again, like take P to a trap state. Okay, and let's call it trap state T and A comma B. Okay, and for Q also, what we'll do is if you get a B over here, then you take it to trap state. Okay, so for input B, and for R also, what we'll do is we'll create another trap state over here, and what we'll call it? We'll call it X, and repeat back with A comma B. Okay, that is, if you get an input of A over here, you'll take it to trap state. Okay, and for S you get an input of, and for over here you get an input of B, you take it to trap state. Okay, now you might be thinking, if we loop it through it, we can accept A B A B A B, we can get that pattern, right? Okay, so just to be clear, let's see now. Yeah, so you get a over here. Let's say we get a string like A B A B. Can we do this over here? We have a string, you get an input of A, you go to state Q. You get another input of A, you go to state R. You get another input of B, you go to state S. And again you have an A, you go to state Q. Again you get an A, you go to state S. R. And from there you get a B, you go to state S. So this A B pattern we can get for infinite amount of time. But can we specifically stop at 1000 times? We can't do that, because then it will have to store that much amount of pattern, and you'll have to manually create just a string like A B for 1000 times like this. This pattern has to be created 1000 times instead of just looping it back. Okay, so that's the problem with remembering a string, because you need a memory for that. So that is what non-regular languages are. Okay, now we'll look at another example what kind of problems a DFA cannot be drawn for, as in a regular language cannot do. So let's say we want a string in our language of the pattern A raised to n and B raised to n. Can we construct a DFA for it? So let's say we have got pattern like A raised to 2, B raised to 2. So whatever is the length of A should be the length of B. Can we do that? We cannot. Why? We'll look at an example. Let's solve this. Yeah, this is the starting place. Let's call it P. Okay, starting state. Then you get an input of A, and you go to state Q. Again you get an input of A, you go to state R. Again you get an input of B, then you go to state S, and you get another input of B, you go to state T. Okay, so a DFA has to be done in such a way that it has to know what is the number of input of A, and it has to replicate the same for B. Can we do that? We cannot, because a DFA won't be able to store it, right? So let's say we construct a DFA, but the number of A's changes, like it becomes 3. Then what you are going to do? You cannot, again and again you'll have to draw a DFA. So there is no automation over here, correct? So you cannot, a DFA cannot store or remember a pattern. That's the problem. Okay, so for that you need a non-regular language. I hope you got the concept of what are regular languages and what are non-regular languages. Regular languages means for which you can create a DFA and a finite state machine recognizes it. Okay, and non-regular languages means it can remember patterns. Okay, so I hope you got this concept. If you have any queries, feel free to ask me in the comment section below. Thank you. So that's it for today, guys. Thank you very much for watching. If you have any queries, feel free to ask them in the comment section below. If you have any suggestions, please write them in the comment section below. If you like the video, please share it with your friends and subscribe to my channel. Thank you very much.